morning. Today is November 11th, and I'm recording this for my Math 261 Applied Calculus 1 class. I did just make an announcement on Canvas that I will have to cancel our synchronous class meeting this morning, but the goal for me today is to have 3 lesson videos uploaded by 5 p.m. today so that you guys can watch those 3 lesson videos, take notes, and I will also upload the completed notes that I take as I'm recording this video, so that you guys can still try the daily problems and your My Math Lab homework. I will move section 2.6 to next week so that I can actually teach that in the class. So I'm very sorry that I won't be able to meet our regular class meeting, but hopefully our first asynchronous lesson goes well today. But I am going to be available by email all day, so if you need anything, just feel free to write me an email or message me on Canvas so that we can talk. Now let me go ahead and get started. Remember, we did start section 2.2. I think we did finish it. Yes, we did finish section 2.2 on Monday, and I did post the notes that we took. We finished section 2.2. That was about derivatives of exponential base e functions. Some fun examples that day. And we also started section 2.3, derivatives of natural logarithmic functions. We did prove theorem 7 in class, that derivative of natural log of x is 1 over x. And after proving that theorem 7, we used that theorem to differentiate a whole bunch of other functions. And we kind of added on chain rule to it. So we combined with this new idea, this theorem 7, and using chain rule, we differentiated more functions. And we did a lot of work, I see. And I see that when we review some product rules on Monday, and it says come back on Wednesday to finish the rest. So in this lesson video, this first one for the day, I will finish example 4. Okay, looks like we stopped on page 3 of section 2.3. So if you guys can open up your 2.3 notes, I have it open right here. So this was posted on Canvas for you. So you already have these notes. But I'm going to go ahead and start back here. So this one will be one of the shorter lesson videos. I will have 3 in total today. I will have 3 lesson videos in total, and this is the first one. I will finish page 3, page 4, and 5, and that's going to be it for section 2.3. Okay? All right, let's go ahead and do that. I don't know how long this will take. I'm thinking about like 40 minutes. What's going on? My pen is not working. Give me 1 second. I think there's a way for me to see if my Apple Pen is charged. Oh, not that one. That's what was happening. So this was very low on battery. All right. But when I'm recording on my iPad, I don't think there is a way for me to pause. So, all right, let me try to use my finger to do this. Okay. Come on. No, it's not going to let me write with my finger. Okay, so let me try this. I plugged it in just briefly. All right, it says find the equation of the line tangent to the graph of f of x equals. So here's my function, natural log of x, and that's getting raised to the 5th power. Okay, and the point that we're interested in is x equals 3. Again, when you're trying to find the equation of a line that is tangent to this graph, we do need 3 things. We need the slope, we need x, and the y value. If you have those 3, we can do point slope form, right? They gave us that x is 3. Now let's find y. Let's find y. Y is f of 3, so we're going to plug in the 3 into the function. Natural log of 3 raised to the 5th power. Now they did say write your answer in slope-intercept form. Do not round until the final answer. So I'm not going to even type that in my calculator. I will go ahead and just wait until I am done with everything. So y is for right now, natural log of 3 raised to the 5th power. Okay? Now let's find m, the slope. Now to find the slope, to find the slope of this tangent line, what we're going to do is find f prime of x. Okay, we're going to find f prime of x. Okay? And this is where we have to use what we learned last class. And in fact, guys, I think we did this very same. Yeah, we did. Look at that. We found it. We found the derivative of natural log of x raised to the 5th power on our example number 2, part D. Well, let's do that again one more time, just for a good review, okay? So down here, I am trying to find the derivative of this function. Let me write down the function. F of x is natural log of x, and that's getting raised to the 5th power, right? So we have to use the chain rule. The outside function is that the inside function is getting raised to the 5th power. And I saw some of you are using this u and v notation, so I loved it. So I'll write that down. I'll use it. So the inside function is natural log of x. So I'm gonna go ahead and use the chain rule over here to find the derivative. So using the outside function, I'm going to apply the power rule, bring down this exponent of 5 in front, and have 5 times natural log of x, and the new power is now 4, went down 1. Now I need to multiply this by the derivative of the inside function, which is natural log of x. Okay? So I keep this 5 times natural log of x to the 4th power. But now let's talk about this. Derivative of natural log of x. The whole main idea from last class was that really. Remember by theorem 7, and we did prove it, we even proved it. Derivative of natural log of x is 1 over x. Okay, and we proved it even, and we used it a couple times. So I'm going to go ahead and replace. I'm going to go ahead and say that is 1 over x. So we found it. F prime of x is 5 times natural log of x raised to the 4th power divided by x. Okay? Now let's find the slope. Slope is f prime of 3. So we'll get 5 times natural log of 3 raised to the 4th power divided by 3. So we have everything. We're ready to do the point slope form. All right, let me go ahead and write down that slope over here. So I got everything. 5 times natural log of 3 to the 4th power divided by 3. So let's do point slope form. Point slope form. Okay. Y minus y1 equals m times x minus x1. All right, x1 is 3, y1 is that expression. Okay, I'm going to evaluate them when I'm done because they did say do not round until the final answer. Y minus natural log of 3 raised to the 5th power equals the slope. 5 times natural log of 3 to the 4th power over 3, parenthesis, x minus 3. Okay? Now, that is an answer, but it's not in decimal and it's not in slope-intercept form, so I'm going to have to keep on going. So y equals natural log of 3 to the 5th power. I did not change anything over there, but let me go ahead and distribute this slope. Okay? So I will get 5 natural log of 3 to the 4th power over 3 times x minus, now notice dividing by 3 over here and this 3 over there will cancel out. So the y-intercept is just going to be 5 times natural log of 3 raised to the 4th power. So let me label everything for you, okay? This right here. Oh, actually, I'm sorry. That's not the y-intercept yet, right? Because now what do we have to do? To have y by itself, I need to add natural log of 3 raised to the 5th power on both sides. I almost forgot about that one. So here we go. Y equals slope of 5 times natural log of 3 to the 4th power over 3x minus, now this is going to be our y-intercept. 5 times natural log of 3 raised to the 4th power plus natural log of 3 raised to the 5th power. I'm going to go ahead and combine those two, okay? All right, I wish I can have more room over here. I mean, actually, you know what? Guys, I'm done. I just need to plug these into my calculator. And I'll do that. I'll do the calculator on my cell phone. Where is my scientific calculator? So you go ahead and type this into on your calculator, and let's see if you and I get the same decimals, okay? So first, the slope. I'm typing in 5 times natural log of 3 raised to the 4th power divided by 3. When I type that in, I got 2 point. Now hold on a second. How did they want us to round it? Round to 2 decimal places. Okay, so I got 2.427, so I'll round that up to 43. So that's what it is. And you know what? I think I drew the parentheses around here, but let me go ahead and get rid of this parenthesis. Oh, not the whole thing. And what I'm about to type in is all that. Okay, I'm about to type in all that because that is the y-intercept. This is the y-intercept. Okay, so you pick up your calculator too and type it in and let us see if you and I get the same thing. I don't know if you can see it on my iPad screen. It's only 7:15 in the morning. I'm just waking up. My babysitter, I don't know, did I tell you why I had to cancel my class today? My babysitter got sick, and I remember teaching our calculus class, which is 3 hours long, the first week without any childcare. Oh my gosh, what a disaster that was. So I decided to just kind of make this class a synchronous class. And speaking of, guys, I'm still working. I'm typing this very slowly. So I typed this in my scientific calculator, and let me hit enter. I hit enter. I got minus 1.790. So I'm going to round it to 2 decimal places. So that is my final answer. Okay. Now, you guys are watching this, and when you are trying this at home, watching this and trying this at home, if you get a different answer, will you please be nice and email me and let me know? Let me know that I typed something wrong on my calculator. But that is what you can do. I mean, this is the same thing that we've been doing since we started, since we talked about derivative, equation of a tangent line. It just looked so much confusing because all this natural log expression, but the answer is just another y equals mx plus b. Alrighty. I think you have something like this on your My Math Lab homework, so try it definitely. Let's go and look at a couple application questions, okay? So example 5 and example 6. Ooh, battery is slow on my Apple Pen. So while I read example 4, let me go ahead and charge this little guy real quick. It's raining in Fredericksburg today. I hope you guys are having a good morning. All right, example 5. The demand for a new smartphone can be modeled by P of x equals 575 minus 45 natural log of x, where P of x is the price consumers will pay in dollars, and x is the number of phones sold. So the price the consumers will pay is a function of the number of phones sold in thousands. Okay, I'll keep reading. Recall that total revenue is given by the number of phones sold by the price. That makes sense, okay? So if one phone is $500, the price is $500. If you want to find the total revenue, you multiply that $500 by how many phones you sold. They want you to find R of x first. Okay, R of x, not with the highlighter, R of x, they told us, is going to be x times p of x, right? And p of x is right there. 575 minus 45 natural log of x. We found it. That was easy. Now, I guess we can distribute if we want to. If you want to. I don't know if that's going to be any helpful. 575x minus 45x times natural log of x. Both are perfectly fine answers. Now they want you to find the marginal revenue, R prime of x. Okay, and I didn't make a little note over here. Marginal revenue is the increase in revenue that results from the sale of one additional unit of output. So if they sell one more phone, what is going to be the increase in revenue? So let's go ahead and find R prime of x first, and we may be able to use that to answer part C. All right, derivative. I'll go ahead and take the derivative of this. Okay, so first, derivative of 575x minus derivative of this 45x times natural log of x. And in this video, I'm trying to be as detailed as possible because I know you're watching this. And during class, you guys can stop me and ask me questions. But right now in this asynchronous lesson, well, I guess you can also drop me a comment or email me if you're not understanding certain parts. But let's go ahead and do this. What is the derivative of 575x? That's just going to be 575, right? Minus. Now, I'm going to go ahead and work with this. I can go ahead and pull out this 45 right now and worry about derivative of x times natural log of x. Okay? Now I'm going to focus on that part now. Okay? That's a product. As you can see, that is a product. Let me minimize this. I write too big today. All right, this is a product. So I'm going to use the product rule. Product rule where f is x and g is natural log of x. Okay? If f is x, then the derivative of f is 1. If g is natural log of x, g prime, the derivative of natural log of x is 1 over x. Okay? So let me go ahead and write down what we know already. R prime of x is 575 minus 45. And we are about to use the product rule here. Okay? Notice, remember, product rule is fg prime plus gf prime. So using these four pieces that we laid out, the derivative of x times natural log of x is x times 1 over x. That was f times g prime plus g times natural log of x times f prime. Now listen, that's f prime is just 1, so I'm not going to write multiplying by 1 because that's not going to change anything. So that blue part, guys, that we just did together, that was the newer part of our lesson. We had to use the derivative of natural log of x. We had to know that is equal to 1 over x. I may be coming down with something. I hope you guys are okay. This weather is crazy. It's November, so in the morning it's like fall and kind of cold, but during the day it's like 70-something. This weather is crazy. All right, let me go ahead and simplify what's inside. As you can see, this x times 1 over x will give me 1, right? And then the natural log of x just comes down. I can go ahead and distribute that 45 and get r prime of x is equal to 575 minus, see, I'm distributing, you guys, 45 minus 45 natural log of x. Okay? I see some like terms. Oh my goodness, my work is getting smaller and smaller. So here's my final answer. The marginal revenue function is, I'm going to combine these two. So 575 minus 45. I don't trust my silly brain at 5:30 in the morning. 575 minus 45 is 530 minus 45 natural log of x. Don't combine those two because they're not like terms. So we found it. I'm going to circle it. So this is the marginal revenue function. Now let's go ahead and find let's actually use this so that it makes sense to us. Like, what did we just find? How many units will be sold if the price that consumers are willing to pay is $550? Now watch very carefully though. They're asking for, because we love to use what we just found, but they're asking for how many units will be sold. Okay? And we're just really looking for the number of phones that will be sold if consumer is willing to pay $550. So X is not 550. What we are getting is that, what does 550 stand for right here? And X is the number of phones sold. So we're looking for X. All right, hold on. Find X. Okay, and consumers are willing to pay $550. P of X, now watch very carefully because these word problems are very tricky. What does P of X is the price consumers are willing to pay. Okay, so they gave us P of X is 550. I mean, like, we just found R prime of X, so I would love to plug that number into R prime of X, but that's not what they want. So we got to read this problem very carefully. So the consumers are willing to pay $550. And because P of X stands for the price consumers are willing to pay, I'm going to say that P of X is equal to 550. When we're doing these calculus word problems, like, you guys are good with calculus part. You know how to find the derivative. Okay, but it's just the word problem part. You have to read very carefully because we don't want to plug in the number they gave us to the wrong equation, right? So here we go. I'm gonna go ahead and write down P of X down real quick. P of X was the original function, 575 minus 45 natural log of X. Okay, I'm gonna go ahead and plug in 550 into the P of X to the left side of the equal sign and go ahead and write down the rest of them exactly the same. And then I will solve this for X. Okay, so this isn't really calculus anymore. This is pre-calculus. This is the kind of equations that we solved back in section 2.1. Now, I'm going to go ahead and say that side is negative 25. And if I bring down negative 45 natural log of X, the next step is for me to divide both sides by negative 45. So if I simplify, that will be 5 over 9 equals natural log of X. Okay? Now, how do we solve this? I'm going to go ahead and rewrite this in exponential form. Rewrite in exponential form. I don't know if you can hear my dog snoring. He is so distracting. Jack! Okay, he stopped. All right, so e raised to the x power. I'm sorry. E raised to the 5 over 9 is equal to x. Why? Because when they say natural log of x equals 5 over 9, put that dog back in his crate. Go in. So distracting, you guys. All right, so that is log base e of x equals 5 over 9, right? So the base is e, the power is 5 over 9, and this x is the answer. So I think we found it. So let me go ahead and type this into my calculator. E raised to the 5 over 9 power. E raised to the, where's my e? E raised to the 5 over 9. Evaluate. And I got 1.74290. Okay? But I'm sure they're not talking about selling 1.74294 phones. So was the unit in just single unit? Let me go up and see. Oh, here we go. X is a number of phones sold in thousands. So we're not talking about 1.7 phones. We're talking about that times 1,000. So let me go ahead and finally multiply this. 1.7429 times 1,000. And that is going to be our answer. So that will be 1, 2, 3 to the right. 1740, let me round that up. 1743 phones. Okay, so that is my final answer. So if consumers are willing to pay $550, then they'll be able to sell 1743 phones. Now, this one was kind of I don't know, I'm a little disappointed in this example because I found R prime of X and I wanted to use my derivative, but they just kind of wanted to have the marginal revenue function, but we really ended up just using the original function, P of X, to answer that part C. I would totally add part D and E and F so that we can use the marginal revenue. But anyways, that looks like that's it for example 4 or 5. All right, let's do the very last one, example 6. All right, social science, forgetting. In the psychological experiment, students were shown a set of nonsense syllables such as POK, RIZ, DEQ, and so on, and asked to recall them every minute thereafter. So it's like a memory game, huh? So you show them a whole bunch of random words, and then tell them to memorize it. And then every minute you ask them, what do you still remember? So, we forget stuff. So I can see why this function they gave us, this graph is going down from left to right, because we'll forget more stuff. We will remember less words. All right, so what? The percentage of R of t who retained the syllable after t minutes was found to be given by the logarithmic learning model. Oh, I love this. It's the actual application of what we are doing. So looks like because t stand for numbers, so it looks like they took measurement after 1 minute and then they stopped taking measurement after 15 minutes. So you show them these words, and after 1 minute, you ask them and you count how many people still remember all these things. And you keep on doing this until close to 15 minutes. So it looks like they got data up to 14 minutes. All right, anyways, so what are we doing here? First question, what percentage of students retain the syllable after 1 minute? All right, they're simply asking us to find R of 1. That is 80 minus 27 times natural log of 1. Okay, now listen, 80 minus 27 times, do you remember what natural log of 1 is? Okay, what is that? Okay, now we talked about all these basic ones before, but if you want to use a calculator, I don't mind at all. But this is log base e of 1 equal to a question mark, right? So if I rewrite it, it's going to be e raised to something power, some power giving us 1. Now remember, anything to the 0 power is equal to 1. So natural log of 1 is just 1. Now you can just type this in your calculator if you want that. I'm sorry, not 1. That was 0. Remember, the power was 0, right? The power was 0. We were solving for e to the unknown question mark equals 1. So that unknown question mark was 0. I almost made a mistake. Whew. So that is 80 minus 0. Well, so that it's just going to be 80. So what we got is 80% of the students will retain the syllable after 1 minute. So, wow, so 20% of these students already forgot it after 1 minute. So still doing good. 80% still remember what is going on. And you know what? I mean, I did plug into the function, but I could even read it over here. They gave us this nice graph. So after 1 minute, I can see 80% of students still remember these syllables. Okay. Now let's talk about r prime of 2. Now we have to find the derivative this time. So let's first find r prime of t. So r of t was 80 minus 27 natural log of t. Let's find the derivative of this. Okay. Now again, guys, I'm doing this very, very slow today. D of dt, because maybe I'm just waking up too, but I get so worried, you know. I'd rather do this in class with you. But hopefully you can learn and, watch and learn. All right, so derivative of 80, what's that going to be? Well, just 0, right? Minus, I can pull out this 27 to the front and just deal with that later. So now I just need to find the derivative of natural log of t. And we know what this is. We know what this is, right? R prime of t is equal to, let me not write down the 0, negative 27 times. What is natural log of, the derivative of natural log of t? 1 over t. So R prime of t is negative 27 divided by t. So now let us find what they want. They wanted you to find r prime of 2. That will be negative 27 divided by 2. So now I think the unit is the percentage points. So what is half of negative 27? Negative 13.5. So I can say it's going down by 13.5 percentage points. Oh, I think I have the fill in the blank answer right here. So let's go ahead and fill that out. This result indicates that, the 2 minutes, I think there should be that. 2 minutes after students have been shown the syllable, the percentage of them who retain the syllable is decreasing, or I can say shrinking, you know what, I'll just say going down. It's going down because this was negative, right? Because it was negative at the rate of 13.5% per minute. Because what we found is the rate of change. Remember, derivative is, when we were writing equation, that was a slope of a tangent line. But this is really instantaneous rate of change, or just the rate of change at that moment, after 2 minutes. So because it came out to be negative, I can say it's going down, and at that rate of 13.5% per minute. Let's do the last one. When will the percentage of students who retain the syllable drop to 20%? So if you are looking for the percentage of students who retain the syllable, which function should you use? We should use this R of t, because look, R of t is the percentage of students who retain the syllable after t seconds. So I know we found the derivative and all, but unfortunately, we're not going to be able to use that for our very last problem. We go back to the original problem. So try to practice reading very carefully and then picking out which equation that you're going to use. That's what's hard about word problems, isn't it? All right, so let's do this. R of t. What was R of t? Now my cat's running around the house like crazy. This house is crazy. 80 minus 27 times natural log of t. That was R of t. We're going to say r of t equals 20. Now I can see someone may ask, why don't we plug in t equals 20? Because what does t stand for? T stands for number of minutes, right? So when they gave us 20%, 20% is not a t value. So let's go ahead and say 20 equals 80 minus 27 times natural log of t. I hear my boy crying. He just woke up. I'm going to go ahead and send him to kindergarten and then come back and finish. But I think I'm almost done. I'm going to let him cry a little bit. Minus 60 equals negative 27 natural log of 27 times natural log of t. Divide both sides by negative 27. So I got 60 over 27. I think I can simplify that, reduce that fraction, but I'm just going to go on. Okay? So if I rewrite this in exponential form, t is equal to e raised to the 60 over 27. Sorry, I feel rushed right now. I feel like I need to go upstairs. All right, almost done though. So let's type in e raised to the 60 divided by 27. That comes out to be 9.22781. ... How did they want you to round it? Didn't really mention it. So what will be the percentage of students who retain the syllable after when will? So around 9.22 minutes. Oh dear. All right, what I'm going to do is I'm going to check this answer by looking at the graph. So around 9.22 minutes. Around 9.22 minutes, somewhere around here. We should see 20%. Oh, that's looking amazing. Alrighty, so that's enough for this lesson. I'm going to go ahead and stop this video and, process it and put it on YouTube and share the link with you. I will be back and I will teach you lesson 2.4 in another video. So I'm going to also post this notes on Canvas. I don't know if you can hear that boy crying like crazy. But that's it for section 2.3, you guys. I will be back with other lesson videos today. All right.